It says two 2p orbitals can combine to form molecular orbitals in a few different ways. Draw a sketch of the overlap between these two atomic orbitals that would produce a sigma bonding molecular orbital. So sigma means that the electron density lies primarily or symmetrically along the axis of the two nuclei. So another way of saying that is that the electron density is between the two nuclei. And electron density is another way of just saying where the electrons are or where the orbital is. So between two nuclei. Bonding means that we're going to add two orbitals, or that the two orbitals are going to be in phase, since p orbitals have phase. Now, let's see. Okay. And okay, yeah, that's all we need. That's the hints here from these two words. And the molecular orbital part means we're going to take two orbitals, we're going to bring them together. Where they overlap, we're going to add. So there's actually two ways that you can bring p orbitals together to create molecular orbitals. One of them starts with p orbitals along the same axis, such that they come together head to head or end to end. The other way of doing it, and this is not what we need, but there is, is this 2p? Oh yeah, 2p. So if you bring the 2py orbitals together, you're going to get a pi bond because they will overlap above and below the axis of the nuclei. If you do 2px, they will form a sigma bond. And of course, if you do 2pz, they will do the other pi bond. That's why there's two pi bonds and one sigma bond in the molecular orbital energy diagrams for these. But we're going to do the green ones. We're going to bring them together. And they're supposed to be the same size, but oh well. There we go. And where they overlap, and then I've shown a bit more overlap than I typically do, but hopefully you get the idea. They will be bigger. And bigger means that there will be a higher probability of finding the electrons there. At this right, the highest point will be right in the middle. There is probability out here as well, but to draw that nicely, it will look something like this. It will still have two nodes in it where the nuclei are, and it will have smaller parts outside and a bigger part here. This is sigma 2p, regardless of what the atoms are. The only thing that changes when you get different atoms is actually the size of the atoms and therefore the size of this. But yeah, that's what it looks like. Sketch. Yep, so our process would look like this, 2px, show them overlapping, and then actually show the sigma 2p molecular orbital.